Find the maximum power that can be delivered to the resistor R in the circuit in figure. We have to find the maximum power that can be delivered to the resistor R in this circuit. So the remaining circuit will be solution. For maximum power transfer theorem, RTH is equal to RL. So this is our RL and the remaining circuit will be RTH. So we have to find RTH. To find RTH, we will turn off all the independent sources. This will be RTH. If we turn off the voltage source, this will be short circuited. This is also voltage source, so this will be short circuited. This is a current source, this will be open circuited. Now RTH will be equal to, this 3 ohm is in series with 5 ohm, so this will be 8 ohm. 8 ohm parallel with 2 ohm. So this will be 8 into 2 divided by 8 plus 2. So 8 into 2 divided by 8 plus 2. So it is 1.6 ohm. Therefore RTH is equal to 1.6 ohm. We have to find maximum power. Pmax is equal to VTH square by 4 RTH. Now we have to find next VTH. To get the Pmax, we have the value of RTH. To find VTH, this will be VTH. This is VTH. Let's say this is current I. First we will convert this current source into its equivalent voltage source. So its equivalent voltage source will be in series with this 5 ohm. This is positive and this is negative according to the direction of this current, and V is equal to I into R. I is 6 and R is 5. So 5 into 6 is 30 volt. This is positive and this is negative. Let's assume this is current I. So apply KVL to the loop. We will start from here. So this will be minus 20. This will be plus. This will be minus. Plus 3 into I. Plus 3 into I. Then this will be plus minus plus 2 into I. Plus 2 into I. Minus 10. Minus 10. This will be positive. This will be negative. Plus 5I. Plus 5I. Minus 30 is equal to 0. Minus 30 is equal to 0. So this will be 3 plus 2 5. 5 plus 5 10. 10I, and this will be minus 20. Minus 10 minus 30. Minus 30 minus 30 will be minus 60 is equal to 0. So 10I is equal to 60. 10I is equal to 60. Therefore I is equal to 6 ampere. We have to find the value of VTH. So let's say this is loop number 1. Loop 1. Now we will apply KVL to this loop. Apply KVL to loop number 2. We will start from here. This will be plus 2I. Plus 2I. Minus 10. Minus 10. Then minus VTH is equal to 0. Minus VTH is equal to 0. So this will be 2 into I is 6. minus 10 minus VTH is equal to 0. So this will be 12 minus 10 is 2 minus VTH is equal to 0. Therefore VTH is equal to 2 volt. Now we have the value of VTH and RTH. From this we can find P max. P max is equal to VTH square by 4 RTH. Now VTH is 2 square divided by 4 into RTH. This RTH is 1.6 ohm. 1.6. So this will be 2 square 4 by 4 into 1.6. So this is 0.625. The unit of power is watt. So therefore P max is equal to 0.625 watt. What we have to find? We have to find maximum power that can be delivered to the resistor R. So this is the maximum power that can be delivered to resistor R. The variable resistor R in figure is adjusted until it absorbs the maximum power from the circuit. A. Calculate the value of R for maximum power. B. Determine the maximum power absorbed by R. Solution. We have to find R for maximum power. So for R, when R is equal to RTH, that time the power is maximum. So we have to find RTH. To find RTH, we will turn off all the independent sources. Here in between this will be RTH. We will turn off all the independent sources. Since this is a voltage source, this will be short circuited. Now as we can see that 80 ohm parallel with 20 ohm, RTH is equal to 80 ohm parallel with 20 ohm plus it is in series with 10 ohm parallel with 90 ohm. 10 ohm parallel with 90 ohm. This will be 80 into 20 divided by 80 plus 20 plus 10 into 90 divided by 10 plus 90. So this is 80 into 20 divided by 80 plus 20 plus 10 into 20 divided by 10 plus 20. This is 90 because here it is 90. So this will be 90 by 90. So it is 25 ohm. This is the value of RTH. Now RTH, this is our answer A. R is equal to RTH is equal to 25 ohm. For B, determine the maximum power absorbed by R. So this is our B. P max is equal to VTH square by 4 RTH. We have the value of RTH but we don't have the value of VTH. So to find VTH, here this will be VTH across this resistor R. This is VTH, this will be positive, this will be negative. Now to find VTH, let's assume this is loop number 1 with current I1 and this is loop number 2 with current I2. So apply, we will use mesh analysis here. apply KVL to mesh number 1. At mesh number 1, this will be positive, this will be negative. Here this will be positive, this will be negative. We will start from here. So this will be plus 80 into I1, then plus 20 I1, then this will be minus 40 is equal to 0. So this will be 80 I1 plus 20 I1, this will be direct 100. So 100 I1 is equal to 40. Therefore I1 is equal to 40 by 100. So this is equal to 0.4 ampere. Next we will apply KVL to mesh number 2. Apply KVL to mesh number 2. This will be positive, this will be negative. Here this will be positive and this will be negative. We will start from here. So this will be 40 plus 90 I2 plus 90 I2. Now this will be plus 10 I2 plus 10 I2 is equal to 0. So this will be 40 plus 100. 40 plus 100 I2 is equal to 0. So this will be 100 I2 is equal to minus 40. Therefore I2 is equal to minus 0.4 ampere. We have to find this VTH. So let's say this is mesh number 3. This is mesh 3. So apply KVL to mesh 3. So this will be positive, this will be negative, positive, negative. We will start from here. So this will be plus VTH, then this will be plus 90 into minus I2, plus 90 into minus I2, then plus 20 into minus I1, plus 20 into minus I1 is equal to 0. So this will be VTH plus 90 into minus I2. Now I2 is minus 0.4 plus 20 into minus I1 is minus 0.4 is equal to 0. So this will be 28. 90 into 0.4 plus 20 into minus 0.4. So this is VTH plus 28 is equal to 0. Therefore VTH is equal to minus 28 volt. Now we have the value of VTH and RTH. So we can find P max. P max will be equal to VTH square by 4RTH. VTH is minus 28 square divided by 4 into RTH. Now RTH is 25 ohm. So this is 25. So this will be minus 28 square divided by 4 into 25. 7.84 watt is the value of P max. 7.84 watt. Find the maximum power transferred to resistor R in the circuit of figure. Solution. First we will find RTH. So to find RTH, here this will be RTH. We have to find maximum power in this resistor R. So this will be RTH. Now we will turn off all the independent sources. So this is a voltage source. This will be turned off and short circuited. Here we can see this is a dependent source. So to find RTH, we will consider a 1 volt voltage source here. This will be positive, this will be negative, this will be 1 volt. Let's say this is current Ix. So therefore RTH will be equal to 1 volt divided by Ix. Now we have to find this Ix to get the value of RTH. Let's say this is node VO and this is node, this will be node of 1 voltage. So let's say this is VA is equal to 1 volt. Let's say this is a reference node. Let's say this is current I1, this is current I2 and this is current I3, this is current I4. So apply KCL at node VO. Now when we apply KCL at node VO, so entering current at this node is 0. So all the currents are leaving. So I1 plus I2 plus I3 is equal to 0. I1 plus I2 plus I3 is equal to 0. Now this I1 is equal to VO minus 0 by 10. VO minus 0 by 10 kilo ohm. So 10k plus I2. I2 is VO minus 0 by 40k. VO minus 0 by 40k plus I3. Now I3 is VO minus 1. VO minus 1 by 20k. VO minus 1 by 20k is equal to 0. Now we have to find the value of VO from this equation. So this will be VO by 10,000 plus VO by 40,000 plus VO by 22,000 minus 1 by 22,000 is equal to 0. So this will be 1 by 10,000, 1 by 10,000, then plus 1 by 40,000 plus 1 by 22,000. So this will be 170.45 into 10 raised to the power minus 6 VO minus 1 by 22,000 is equal to 0, or directly we can write this is equal to 1 by 22,000. So from this VO is equal to 1 by 22,000 into this. So this will be 1 divided by 22,000 into answer. So this will be 0.266. 0.266 volt is the value of VO. 4 by 15. For more precise, we will write 4 by 15 volt. Now we have the value of VO. From this we can find the value of Ix. So Ix will be equal to If we apply KCL at node VA, apply KCL at node VA, so summation of all the entering current is Ix plus I3. Ix plus I3 is equal to I4. Also this 0.003 VO is entering at this node, so this will be I3 plus Ix plus 0.003 VO is equal to I4. So this Ix as it is plus I3. Now I3 is VO minus 1 by 22,000. VO minus 1 by 22k plus 0.003 VO is 4 by 15. 4 by 15 is equal to or minus I4. Now I4 is, this I4 is 1 minus 0, 1 minus 0 by 30,000. 1 minus 0 by 30k. So this will be Ix plus VO is 4 by 15. So 4 by 15 minus 1 divided by 22,000 plus 0.003 into 4 by 15 minus 1 by 30,000 is equal to 0. Ix, and this will be 4 by 15 minus 1 divided by 22,000 plus 0.003 into 4 by 15 minus 1 by 30,000. So it is 733.33 plus 733.33 into 10 raised to the power minus 6 is equal to 0. Therefore Ix is equal to minus 733.33 into 10 raised to the power minus 6 ampere. This is the value of Ix. We have to find RTH. RTH is equal to 1 by Ix. RTH is equal to 1 upon Ix. So this will be 1 upon minus answer. So it is 1363 minus 1363.63 ohm. This is the value of RTH minus 1363.63 ohm. Now this RTH is in minus. Next we have to find VTH. We have to find the maximum power transferred to resistor R. Since the RTH is negative, therefore Pmax is equal to, directly we can say Pmax is equal to infinite. So this is our final answer. Determine the maximum power delivered to the variable resistor R shown in the circuit of figure. Solution. We have to find P max. P max is equal to VTH square divided by 4 RTH. So we have to find VTH and RTH. First we will find VTH. To find VTH, we will redraw the circuit. Now here this will be VTH. Positive, negative, VTH. Now here we can see this is open circuited. So this Vx is equal to 0. Now since this Vx is equal to 0, this dependent current source will be 0 because it is 3Vx. 3 into 0 is 0. So this will be open circuited. So this will be our VTH. Voltage across this 15 ohm is the value of VTH. So we can apply voltage division rule to find the voltage across this 15 ohm resistor. So V 15 ohm is equal to VTH is equal to this voltage 4 into this resistance, which is 15 divided by 15 plus this value 5 ohm. So this will be 4 into 15 by 15 plus 5. So it is 3 volt. Therefore this is the value of VTH. VTH is equal to 3 volt. Next we have to find RTH. To find RTH, here we can see that this is a dependent source. So to find RTH, here we will consider a 1 ampere current source. One ampere current source. Now let's say this is node V1 and this is node V2. So RTH will be equal to V2 divided by 1. This 1 ampere into RTH is equal to V2. So therefore RTH is equal to V2 by 1. Now to find RTH, we have to find the value of V2. So let's assume this is current I1, this is current I2, and this is a reference node. This is current I3. Now we will apply KCL at node V1. Apply KCL at node V1. So this will be I1 is equal to I2 plus I3 plus 3Vx. I2 plus I3 plus 3Vx. Now I1 is equal to 4 minus V1 by 5. 4 minus V1 by 5 is equal to I2. I2 is V1 minus 0 by 15. V1 minus 0 by 15 plus I3. I3 is V1 minus V2 by 5. V1 minus V2 by 5 plus 3Vx. Now this Vx is equal to 6 into this current. So 6 into 1 is directly Vx is equal to 6 volt. Now this will be 4 by 5 minus V1 by 5 minus V1 by 15 minus V1 by 5 plus V2 by 5, then this will be minus 18. When this 3 into 6 goes on left side, so this will be minus is equal to 0. Now this will be minus 1 by 5, minus 1 by 5, then minus 1 by 15, minus 1 by 15, minus 1 by 5, minus 1 by 5, so this is minus 7 by 15, minus 7 by 15 V1. This will be plus V2 by 5. Now this will be 4 by 5 minus 18. 4 by 5 minus 18. So it is minus 17.2. So it will be is equal to 17.2. Let's say this is equation number 1. Now we will apply KCL at node V2. Apply KCL at node V2. So this will be 3Vx plus I3 plus 1. 3Vx plus I3 plus 1 is equal to 0. All the currents are entering. There is no leaving current from this node. Now this 3Vx. So this will be 3 into Vx. Now Vx is equal to again Vx is equal to 6 into 1. So it is 6 volt plus I3. I3 is V1 minus V2 by 5. V1 minus V2 by 5 plus 1 is equal to 0. So this will be 18 plus V1 by 5 minus V2 by 5 plus 1 is equal to 0. So this will be V1 by 5 minus V2 by 5 and this will be 19. So is equal to minus 19. This is equation number 2. Now solving equation 1 and 2. Solving equation 1 and 2 we get mod 5 1 minus 7 by 15 1 by 5 and this will be 17.2. 17.2. Now from equation 2 this will be 1 by 5. 1 by 5 minus 1 by 5 minus 1 by 5 is equal to minus 19. So minus 19. This will be V1 is equal to 6.75. V1 is equal to 6.75 volt and V2 is equal to 101.75. 101.75 volt. We have to find the value of V2. So V2 is equal to 101.75. RTH is equal to V2 by 1. RTH is equal to V2 divided by 1. So therefore RTH is equal to 101.75 ohm. RTH is equal to 101.75 ohm. Now we have the value of RTH and VTH. So we can find the value of Pmax. Pmax is equal to VTH square divided by 4 RTH. So VTH square is 3 square divided by 4 into RTH. RTH is again 101.75. So this will be 3 square divided by 4 into 101.75. So it is 22.11 milliwatt. 22.11 milliwatt. This is the value of Pmax. Pmax is equal to 22.11 milliwatt. For the circuit in figure, what resistor connected across terminals AB will absorb maximum power from the circuit? What is that power? Solution: we have to find the value of RL for maximum power. So RL is equal to RTH. This is the condition for maximum power. RL is equal to RTH. Also we have to find what is that power. So that power will be Pmax, and Pmax is equal to VTH square by 4RL. VTH square is divided by 4RL. So we have to find the value of RTH. To find RTH, we will turn off all the independent sources. This is a voltage source, so this will be short circuited. Also we can see that here this is a dependent source, so we will consider a 1 ampere current source here to find the value of RTH. This is 1 ampere and this will be VA. Let's say this is reference node. Now RTH is equal to VA divided by 1 ampere. VA by 1 ampere. Now let's say this is current I1, this is current I2. Now we will apply KCL at node VA. Apply KCL at node VA. So summation of all the entering current is 1 ampere is equal to summation of all the currents leaving the node. So I1 plus I2. I1 plus I2. So 1 is equal to I1. Now I1 is VA minus 120 VO because the polarity is opposite. So VA minus 120 VO by 10,000. VA minus 120 VO by 10,000 plus I2. I2 is VA minus 0 by 40,000. VA minus 0 by 40,000. So this will be 1 is equal to VA by 10,000 plus 120 divided by 10,000 into VO. Now this VO is, here we can see that this VO is equal to 0 because here there is no independent source. So this will be 0 plus VA by 40,000. VA by 40,000. So this will be 1 is equal to VA by 10,000 plus VA by 40,000. VA 1 by 10,000 plus 1 by 40,000. So this is 1.25 into 10 raised to the power minus 4. 1.25 into 10 raised to the power minus 4 VA. Therefore VA is equal to 1 by answer. So it is 8,000. VA is equal to 8,000 volt. From this RTH is equal to VA by 1. RTH is equal to VA by 1. So this is equal to 8,000 by 1. So 8,000 ohm is the value of RTH. So it is 8 kilo ohm. Next we have to find the value of VTH. Now to find VTH, this will be VTH, this will be positive, this will be negative. Let's say this is loop number 1 with current. Let's say this is current I1. Now apply KVL. We have already taken I1 here, so we will consider it as I3. So let's say this is current I3. We will apply KVL to this mesh 3. Let's say this is mesh number 3. We will start from here. So this will be -8. This will be positive. This will be negative. So plus 3000 I3 plus 1000 I3 is equal to 0. So this will be 4000. 3000 plus 1000 is 4000 I3 is equal to 8. Therefore I3 is equal to 8 by 4000. So 8 by 4000 is 2 into 10 raised to the power -3 ampere. This is the value of I3. We have to find VTH. So VTH is equal to this voltage across this 40 kilo ohm. Now we have the value of VO. So this will be 120 into VO. VO is 2 into VO is equal to 1000 into I3. 1000 into I3. So this will be 1000 into I3. So it is 2 volt is the value of VO is equal to 2 volt. So this will be 120 into 2. This will be 240 volt. 240 volt. 240 volt is the value of, here we will write, this is 240 volt. Now we will use voltage division rule. Apply voltage division rule. So V40,000 is equal to VTH. V 40 kilo ohm is equal to VTH is equal to this voltage, which is 240 volt. 240 volt into this voltage, which is 40,000 divided by 40,000 plus 10,000. So 40,000 divided by 40,000 plus 10,000. So therefore VTH is equal to 240 into 40,000. 240 into 40,000 divided by 40,000 plus 10,000. So it is 192. 192 is the value of VTH. 192 volt. 240 into 40,000 divided by 40,000 plus 10,000 is 192 volt. Here the polarity is minus and plus. So this will be minus 240 and this will be minus 192 volt. So this is the value of VTH. Now we have the value of VTH and RTH. We have to find. So RL is equal to RTH is equal to RL is equal to RTH is equal to 8 kilo ohm. 8 kilo ohm and VTH is equal to minus 192 volt. We have to find P max now. So P max is equal to VTH square by 4RTH. So VTH square is minus 192 square divided by 4 into 8000. So this will be P max is equal to minus 192 square divided by 4 into 8000. 1.152. 1.152 watt is the value of P max. For the circuit in figure, obtain the Thevenin equivalent at terminals AB. We have to find the Thevenin equivalent for this circuit. So we have to find RTH and VTH. Solution. This is for A. So to find RTH, we will turn off all the independent sources. This is a current source, so this will be open circuited. This is also a current source, so this will be open circuited. This is a voltage source, so this will be short circuited. And here this will be our RTH. Now RTH is equal to 6 plus 4 plus 2. 6 plus 4 plus 2. So this is equal to 10, 12. So 12 ohm is the value of RTH. Next we have to find VTH. So to find VTH, here this will be our VTH between terminal A and B. This will be VTH. This will be positive and this will be negative. Now to find VTH, we will convert this current source into its equivalent voltage source. So here this will be a voltage source, this will be positive and this will be negative. Now V is equal to I into R. V is equal to I into R. I is 4 and R is 2. So 4 into 2 is 8 volt. Now next is, we will convert this current source into its equivalent voltage source. So here this will be a voltage source. This will be positive and this will be negative. Again 2 into 6 is 12 volt. Now here we can apply KVL to find the value of VTH. Apply KVL to the loop. This is current, let's say this is current I. Let's say this is I. Now we will start from here. So this will be minus 20, then minus 8, then this will be plus, this will be minus, this will be plus, this will be minus. So plus 2I, then plus 4I, then minus 12, then this will be positive and this will be negative. So plus 6I, then plus VTH is equal to 0. Now here we can see this is open circuited, so this I is equal to 0. Since I is equal to 0, so this will be directly minus 20, minus 8, and this will be 0, 0, then minus 12, then it is minus 40. So this will be VTH minus 40 is equal to 0. So therefore VTH is equal to 40 volt. minus 20, minus 8, then minus 12. So this will be 40 volt. Now we have the value of VTH and RTH. We have to find, for the circuit in figure, obtain the Thevenin equivalent at terminals AB. So Thevenin equivalent will be RTH in series with VTH. So this is our RTH and this will be VTH, positive, negative. This will be VTH and this is RTH. VTH is equal to RTH is equal to 12 ohm. RTH is equal to 12 ohm and VTH is equal to 40 volt. This is terminal A and this is terminal B. Next we have to calculate the current in RL. RL is equal to 8 ohm. So this is the answer for B. When RL is equal to 8, we have to calculate the current IL. So IL is equal to question mark. Now IL is equal to VTH by RTH plus RL. VTH is 40 divided by RTH is 12. So 12 plus 8. So this will be 2 ampere. I is equal to 2 ampere. IL is equal to 2 ampere. Next we have to find RL for maximum power delivered. Find RL for maximum power deliverable to RL. So for C, when RL is equal to RTH, so it will be 12 ohm. This is the condition for maximum power transfer. Next we have to determine that maximum power. So that maximum power will be P max is equal to VTH square by 4 RTH. Now VTH square is 40 square divided by 4 into RTH. Now RTH is 12 ohm. So 40 square divided by 4 into 12. So this will be 33.3 watt. This is the value of P max. 33.3 watt. Determine the maximum power that can be delivered to the variable resistor R in the circuit of figure. Solution. We have to find the maximum power. P max is equal to VTH square by 4 RTH. So we have to find this VTH and this RTH. First we will find RTH. To find RTH, we will turn off all the independent sources. This is a voltage source, so this will be short circuited. And here this will be our RTH. This will be RTH. Now as we can see that RTH is equal to this 10 ohm is in parallel with this 20 ohm. So 10 ohm parallel with 20 ohm plus it is in series with this 25 and 5 ohm. So plus 25 ohm parallel with 5 ohm. So this will be 10 into 20 divided by 10 plus 20 plus 25 into 5 divided by 25 plus 5. So this will be 10 into 20 divided by 10 plus 20, then plus 25 into 5 divided by 25 plus 5. So it is 10.83. 10.83 ohm is the value of RTH. Next we have to find VTH. So to find VTH, here this will be our VTH. This will be VTH. This will be positive and this will be negative. Now let's say this is node with voltage VA and this is node with voltage VB. Let's say this is a reference node. Now this will be positive and this will be negative. This will be positive and this will be negative. So here we can say that if we apply, let's say this is loop number 1 with current I1. So apply KVL to loop number 1. So we will start from here. Let's say we will start from here. So this will be minus 20 minus VA, then plus VTH, then plus VB is equal to 0. Now we have to find the VA. VA is the voltage across this 20 ohm and VB is the voltage across this 5 ohm. So we will use voltage division rule. Apply voltage division rule. Now according to voltage division rule, VA is equal to voltage across this 20 ohm. So here this 10 ohm is in series with this 20 ohm. So VA is equal to this voltage, which is 60 into 20 divided by 60 into 20 divided by 20 plus 10. So VA is equal to 60 into 20 divided by 20 plus 10. So it is 40 volt. Next VB is equal to, similarly VB is equal to 60 volt into 5 divided by 5 plus 25. 5 divided by 5 plus 25. So this will be 60 into 5 divided by 5 plus 25. So it is 10 volt. Now from this VA, we can rewrite this equation. So minus VA, so minus 4T plus VTH as it is, plus VB is 10 volt is equal to 0. So this will be minus 40 plus 10 will be minus 30 plus VTH is equal to 0. Therefore VTH is equal to 30 volt. VTH is equal to 30 volt. Now we have the value of VTH and RTH. From this we can find P max. P max is equal to VTH square by 4 RTH. P max is equal to VTH square by 4 RTH. VTH is 30 square divided by 4 into RTH. Now this RTH is 10.83. 10.83. So this will be 30 square divided by 4 into 10.83. So it is 20.83 77 watt. Therefore, P max is equal to 20.77 watt. For the circuit in figure, determine the value of R such that the maximum power delivered to the load is 3 milliwatt. Solution. We have to find maximum power delivered to the load is 3 milliwatt. We have to find the value of R. So we know that P max is equal to VTH square by 4 RTH. Now for maximum power transfer, RTH is equal to RL. So we have to find the value of RTH. To find RTH, we will turn off all the independent sources. Since this is a voltage source, so this will be short circuited. This is also voltage source. This is also a voltage source. So these will be short circuited. And here this will be our RTH. Now RTH is equal to, this R is in parallel with this and this. So 1 upon RTH is equal to 1 by R plus 1 by R plus 1 by R. So from this 1 by RTH is equal to 1 by 1 plus 1 is 3. So 3 by R. Therefore RTH is equal to R by 3. This is the value of RTH. Next we have to find VTH. So to find VTH, here this will be our VTH. This will be VTH. This will be positive and this will be negative. Let's say this is node with voltage VTH. So let's say this is reference node. Let's say this is current I1, this is current I2 and this is current I3. Now if we apply KCL at node VTH, apply KCL at node VTH, so this will be summation of all the entering current and is equal to summation of all the leaving current. There is no leaving current, all the currents are entering. So I1 plus I2 plus I3 is equal to 0. I1 plus I2 plus I3 is equal to 0. Now I1 is 1 minus VTH, 1 minus VTH by R. 1 minus VTH by R plus I2. I2 is 2 minus VTH by R. 2 minus VTH by R plus I3. Now I3 is, this is I3, 3 minus VTH by R. 3 minus VTH by R. This is R is equal to 0. So this will be 1 minus VTH plus 2 minus VTH plus 3 minus VTH is equal to 0 divided by, this will be R. So this R, when it goes on right side, so this will be 0. So 1 minus VTH plus, or this will be directly 1 plus 2 is 3, 3 plus 3 is 6. So this will be 6 and this will be minus VTH and minus VTH will be minus 3 VTH is equal to 0. So this will be 3 VTH is equal to 6. So from this VTH is equal to 6 by 3 is 2 volt. This is the value of VTH. Now we have the value of VTH and RTH. Also we have the value of maximum power delivered to the load is 3 milliwatt. So this is equal to 3 milliwatt. Now we will substitute all the values. So this is equal to VTH square. VTH square is 2 square divided by 4 into RTH. Now RTH is equal to R by 3. R by 3. Now this is equal to 3 milliwatt. So 3 into 10 raised to the power minus 3. Now we will simplify this. So this will be 2 square is 4. This 4 will get cancelled with this 4. So here this will be cancelled with this one. And this will be 3 by R. This is 1 by R by 3 is 3 by R is equal to 3 into 10 raised to the power minus 3. So from this R is equal to 3 divided by 3 into 10 raised to the power minus 3. So therefore R is equal to, this will be 1 by 10 raised to the power minus 3. So this will be 1000 ohm, or R is equal to 1 kilo ohm. What we have to find? We have to find the value of R. So here this is the value of R.